It's a cylinder, so it goes up and down. Your set is free. This is the first one. So what I think here is, when you have the equations at the left, what the problem suggests, it's easier to draw that way. But changing it into polar coordinate system, well, cylindrical coordinate system, will help us integrate some problems. But in terms of drawing, I think these equations are sufficient. This one is a bit unusual for us to draw. So when we try to draw, I will try to focus on like this kind of equations. For the second one, x squared plus y squared is 4y. So the left hand side is as usual, r squared. Y is r sine theta. So you are cancelling r. You get r is 4 sine theta. For this equation, of course, I don't think it's easy to draw. So what I suggest is do the perfect square if you have to draw a surface. Again, this one is a cylinder. But what kind is it? I am going to move 4y to the left and perform a perfect square. So I add 4. X squared plus y minus 2 squared is 4. So this is a cylinder where Z is free. The projection is a circle on xy plane. It's a circle of center 0, 2 and radius 2. This is your x, y, and z is 3. So the projection x is 0 and y is 2, it appears here. Your projection is a circle of radius exactly 2. So the center x0, y2 here moves to the left and right for 2 units because the radius this time is 2. It corresponds to how you visualize this equation in 2D. Okay? This equation in 2D is a circle, right? Of center 0, 2, radius 2. It's 2 squared, so r is 2. So your circle is going to touch the z-axis, but then z is free, so it goes up and down. In terms of the cylindrical coordinate system, it says r equals to 4 sine theta. If you want to remind yourself, that is 3, the same as the first one. For number 3, y equals x, this is just the r cos theta is r sine theta. sorry, sine equals, I mean, it's correct, but I don't want to flip the side right away. So you get tan theta is 1, right? You move cos theta to be a denominator, you get sine over cos, which is tan. Number 4, you get for x squared plus y squared is z squared. So 4r squared is z squared. You can simplify, but not much, because when you take square root, you get plus minus. So 2 z is plus minus 2r. You guys remember this cone? How does it look like? The cone has two faces, right? The orientation, what is the orientation? It's opening to which axis? Z and Z, right? Center is, the center here is 0, 0, 0. Number 5 is ellipsoid, so r squared plus 4z squared is 9. This is as much as we can do. It's an ellipsoid, it just looks like a rugby ball. And like this. Okay? So on the other hand, from the equations from cylindrical coordinate system, you can change it to rectangular coordinate system. This I will not focus that much, because in practice you're going to see equations where everything is written in form in terms of rectangular coordinate system. And then you are supposed to change it to the cylindrical coordinate system. But I'll just do like a few of these, right? To remind you what the surfaces look like. The first one, z equals 3r. So this is the z equals 3 square root x squared plus y squared. I take the square, so z squared is z squared is 9x squared plus 9y squared. So what is the surface? Cone, right? Is it like full one? No. Good. Because it has a square root. So z is supposed to be greater than or equal to 0. Because we are starting from like this, so this is a half cone. Number 2, I'm pretty sure you can do, is a cylinder. For number 3, this is a cylinder. For number 3, if you have just cos and sine, you cannot change to x and y just yet. You can just move r to the left hand side in order to have r cos and r sine. This one is 2x plus y is 6 minus 7. If we have a linear equation like this is just a plane, right? And usually I'll ask you to draw it in the first octant. So if you have to draw y sat 0 gets x3, x sat 0 gets y6, and xy0 gets sat 36. So in the first octant, it's going to look like sort of triangle. The last one, theta is pi over 3. I think the best thing to do is you take the tangent to change it into y over x. Tan pi over 3 is square root 3. So y is square root 3x. But this one is a little bit scary because if we consider setup being pi over 3, it will mean that both x and y must be in the first quadrant. So the case y and x being negative are not counted here. This is going to be a half plane. I mean, this one is just difficult in its nature. So you have like a half plane where z is free. So here we go. We are going to change a triple integral in the rectangular coordinates to cylindrical coordinates. I assume that you guys don't care so much about how we change it, like the equation, like lots of complicated equations. So I think it's best to just tell you the formula. Is it alright? Or anyone wants to know? If you want to know, read a book. You slice things into pieces, like the same concept of integration. But here is how we do it in practice. So suppose that we have the solid E. It looks like this chunk. You are going to determine first the possible set values, which will be coming from the lower surface, to the upper surface. You have to figure out what surfaces are. That will help you determining the values of set. And your set is usually still in form of R zeta. In form of xy, and then you can change it into R zeta. That's your first integral, the innermost one. Once you do this, you are trying to project the solid onto the xy plane. Meaning that I want to find the widest part as possible. Once you project the solid onto the xy plane, you are going to change that projection, which is now in 2D. You change xy to R zeta. This is how you generally determine the domain of integration when you change the usual triple integral to the cylindrical one. And of course, when you change the domain integration, you also have to change the function that you are integrating, right? So now you change your x to r cos theta, change your y to r sin theta. And most importantly, you're gonna have the factor r being multiplied. It's similar to how we do integration in polar coordinate system in 2D, where when you derive from lots of complicated equations, the r will appear. So when you change it, the factor r must occur. This is very important. You have extra factor r. I want to do the triple integral x y squared dv, where E is a solid lies under the elliptic paraboloid. Okay. Z equals 4 minus x squared minus y squared, and above the xy plane. The elliptic paraboloid is like the upside down cup, right? First, I want to consider the 4x squared, 4 minus x squared minus y squared. You know what surface is it? I mean, just show you one. It's an elliptic paraboloid. It means like it looks like a cup shape. The negative sign in front of x and y indicates that it's upside down. And what is a vertex? Zero, 4. Good. So the vertex is 0, 0, 4. You have a few ways to figure out what vertex is. The first one is if you memorize the standard form. The second one, which I don't know, I prefer this way, is, well, it's in this form. So you're gonna have the maximum set, right? X squared minus x squared minus y squared must be non-positive. So your set here must be at most 4. And that represents the highest point. This is because x squared plus y squared must be non-negative. Now I'm going to consider the first variable of integration, which is z. Z will go from the, so the question says that you want to find solid that lies under this elliptic paraboloid and above the xy plane, so just like this. What is the lower surface? Z equals 0, right? It's on the floor. What's the upper one? The ellipsoid, right? And the paraboloid. So your set starts from the floor. Set starts from 0 to z equals 4 minus x squared minus y squared. When I change this to the cylindrical coordinate system, you get z equals 4 minus r squared, right? Because minus x squared minus y squared is minus r squared. So now you get the domain of integration for z. Next, I'm going to project this onto the xy plane. So what is the widest part of the elliptic paraboloid? It's when z is 0, right? Z is 0. So project. Widest part is z is 0. So when z is 0, you are projecting the elliptic paraboloid. So you have z equals 4 minus x squared minus y squared. You're going to get x squared plus y squared is 4. This is a circle of radius 2. Now in 2D, it's going to be circle of radius 2. Taking the whole region. The second one, now I have to find the possible value of R. It will start from the origin. That's how the polar coordinate works. So from the origin, I expand the radius from the origin to the boundary of the surface, the region. So your R starts from which value to which value? From 0 to from 0 to 2, right? Because the outermost region, that is when it touches the circle x squared plus y squared is 4. This comes from x squared plus y squared equals 4, which is r squared. So your r is 2. And your zeta, I'm starting from the positive x-axis. This is how the polar coordinate works. So your zeta is taking the whole round, right? The full round, the full lap. So it will start from 0 to 2 pi. It takes a full lap. So all in all, I'm going to change this into the triple integral in terms of the z, the zeta. Your z starts from 0 to 4 minus r squared. R goes from 0 to 2, and zeta goes from 0 to 2 pi. Your xy squared, change them in terms of r and zeta. So x is r cos zeta, y is r sine zeta squared. Don't forget the final touch. You're gonna have to add the extra r. the rest is about calculation. I know that one question is very long. That is the nature of triple integral. There may be some questions I'll ask you to set up the integrals without calculating. That will help you doing just half of it, like the whole process. So integrate with set. The function has nothing about set, right? So it's as if you are integrating a constant. So no set. Integrate constant. So you have integrate 0 to 2 pi, 0 to 2 r to the 4th cos theta sine square theta set from 0 to 4 minus r square dr d theta. So r4 cos theta sine square theta. I'll just factor this out, and then I have 4 minus r square minus 0 dr d theta. I multiply the r to the 4th with this guy. So the r terms, what I have here is 4r to the 4th minus r to the 6th. Now you integrate this with respect to, sorry, then we have dr d theta. So think of the theta as constants. You are going to just integrate 4r to the 4th minus r to the 6th. So 4r to the 5th over 5 minus r to the 7 over 7. From 0 to 2, cos theta sine square d theta. Whatever you get some large number, I'll tell you that what you have is 256 over 35. I want to do this question to the end just to point out that where you have to use some technique of like integrate trigonometric functions. I'm not sure if you remember how to integrate this. Integrate cos sine square d theta. You sub, right? Take u as the sine theta. du is cos theta d theta. But look, if you take u to be sine theta, when theta is 0, u is going to be 0 because u is sine 0. If theta is 2 pi, you also have u equals 0, which means you reduce it into integrate from 0 to 0 u square du. which is what you should expect, 0. But I'm not going to give you points for guessing correctly. It's long, it's very long. So I think what I'm going to do for final is I'm going to have like an extra couple points I'm not sure if it's going to help you. Like for example, maybe I haven't created an exam yet, but maybe I have like 90 to 94 points divided by 2. That's I cannot divide. How do I divide this up? 47, so maybe 5 extra credits. Something like that. But I'll let you know once I finish creating the exam. Okay. Now the next one. I have to find the volume of E where E is a solid region in the first octant. So x, y, z are 0, bounded by the surfaces. And let me think. Let's simplify this. I overlook when I prepare this section. Z equals square root 1 minus x squared minus y squared, and x squared plus y squared is y. So first I have to see what it's going to look like. The first equation, I take a square. So we get x squared plus y squared plus z squared is 1. With an important note that z is non-negative. What is the surface of this one? Sphere, right? It's half of the sphere because z is positive. Upper half. Radius 1. Center 000. And I am going to also change it right away that this equation in terms of the cylindrical coordinate, it is going to be change x, y, z to r, z, and z. You're going to have r squared plus, I think it's better to change this one. When I change, I have z equals square root 1 minus r squared. Right? The silicon. Likewise for this one, I am also going to change it into the spherical coordinate. So r squared is r sine theta. R is sine theta. But in terms of drawing, I am going to do a perfect square. So I add 1 over 4 to the left and right. This equation is the surface cylinder. Right? A cylinder. When you project on the floor, it's going to be a circle. What is the center? 0.5, right? The cylinder. Where on xy plane in 2D. The center is 0, 1 over 2. And radius is 1 over 2. So the cylinder will appear around here. You have a center of 0 and 1 over 2. This is the center of the projection of the cylinder. The circle has radius 1 over 2, so your circle is touching the boundary of the sphere. And another one is touching the z-axis because it's going left and right for 1 over 2 units. And because it's a cylinder, it goes up and down forever. So your solid that you are considering is this one. It looks like you have a cylinder and then you cut off with some curvy surface. The volume of E is the triple integral of 1 dA. But then when you change to r dr dθ, you have to add factor r as usual. The first variable is z. Z goes from the lower surface to the upper one, which is Z will start from 0, right? The floor to the sphere, right? It goes up like this. It's going from 0 to the sphere. Your sphere you have already Z equals square root 1 minus r squared. This comes from the sphere. Once you get a set, you you project your solid down to the xy plane, right? So next, project onto the xy plane. The widest part is again when Z is 0. Well, it doesn't seem to help much because your region corresponds to the cylinder anyway. So you can assume use the x squared plus x squared plus y squared is y. Well, for this one, your circle, the center is not 0 anymore, right? The floor one. The center now here is at x0, y half. So it corresponds to x0, y half here. The radius is 102, and your circle is touching the x-axis, and at y equals 1. So it's 1 right here. This is your region in 2D. Now be very careful here. Finding the values of r, you are not starting from the center of the circle. You are starting from the origin. So you have to draw from the origin to the end of the circle. So your r starts from 0 to the circle. And your theta starts from the x-axis, which is when the angle is 0. That's when the region of the circle starts to appear until the end, where the x-axis, where it touches the negative x-axis. So your theta starts from 0 to pi. So now we are back to integrating. So the triple integral, you have set starts from 0 to square root 1 minus r squared. R starts from 0 to sine theta. And your theta starts from 0 to pi of r dz dr d theta. The rest is integrating. So integrate r dz. It has no set, so you are integrating a constant. So this is r set from 0 to square root 1 minus r squared dr d theta. R square root 1 minus r squared. And then for this one, you do the u sub. U is 1 minus r squared. I assume that everyone should be able to do at this point. So you have 1 minus r squared over 2 to the 3 over 2. Negative. R from 0 to sine theta. You plug in r being sine theta, you get 1 minus sine square, which is cos square. Cos theta comes from 0 to pi. Through cos square square root wait, did I say the first octant? Oh shit. Sorry. Well, okay, let me cancel the first octant because we worked way too far to go back. But then the whole point here is you also have to separate this into two subregions. Because when you substitute sine theta here, you get 1 minus sine square, which is cos square. And then when you take square root of cos square, you get the absolute cos. So you have to split this into 2, because your theta starts from 0 to pi. From 0 to 2 to pi over 2, square absolute cos is cos. From pi over 2 to pi, you get negative cos. I don't want to continue calculating this, it's too much. You can do with the first octant is easier. That was what I intended at the beginning. But I didn't look at my notes. So then things become much extra hectic here.
เข้าไปใน R แล้วเป็น1ลบไซน์กำลัง2ใช่ไหมเป็นโคดกำลัง2ใช่ไหมเป็นโคดแล้ว
But when you take square root, you get absolute cos. So the value is different from 0 to pi over 2 and pi over 2 pi. That makes things very difficult. I mean, before that I intended to just do the first octant, and the question is easier, you don't have to separate them two. But I forgot. I do without the first octant, so it becomes much more complicated. But anyway, I don't want to focus too much on calculating. In the exam, I'll try to make integrations to be reasonable, not this huge mess. Okay? But I expect you to, in order to like set up the integral correctly, and okay, suppose I have a question in the exam where you have to do this full work. From the beginning to setting up the integral correctly, I may give you like 6 or 7. The other 3 and 4 are calculating. And it's not about if you calculate it correctly. If your process is correctly, I also give you 1 or 2 points. So doing calculation mistake, I'll deduct like 1 or 2 out of 10. Alright, I think last one for today. I want to set up the triple integral. You don't have to calculate, where E is the region inside from the outside. Okay. From the center, this one and the 2 planes. It's not about this room. I'm going to have a heart attack. Okay, for this one, I asked you to set up the integrals. You have a cylinder, again as before. I have the floor, so it's this one floor, z equals 0. This guy is x squared plus y squared is 4y. I'm not going to draw it very accurately. What I'm going to do here is is I'm going to draw just a plane as some slanted plane, okay? So you can see the picture of what it kind of looks like. Okay, I'll continue teaching. I'll try to finish it. So your set now, your set starts from the floor to the upper plane, right? So set will go from 0 to x plus y plus z is 10. This one I will change it into set r cos theta plus r sin theta plus z is 10. So the set is 10 over r cos theta plus r sin theta. And now you are projecting the region onto the xy plane. Of course, your projection is the projection from the cylinder. So we are going to deal with this equation. In terms of the spherical coordinates, you have r squared is 4r sine theta, which is r equal to 4 sine. About drawing, I do a perfect square. So you get x squared plus y minus 2 squared is 4. Radius 2, center 0, 2. So your R will start from the origin to the end of the circle to 4 sine theta, and your theta will start from 0 to pi because the angle sweep through from 0 to pi. So your integral, the final integral is from going from 0 to 10 over r cos theta plus r sin theta, from 0 to 4 sine theta, theta from 0 to pi, f r cos theta, r sin theta, z times r dz dr dz. Okay, so that's all we have for today. Before you go, Because after midterm we are losing 4.5 hours of classes. I'm asking you in two options you can choose. First one is extended every class for half an hour. So instead of one and a half hour, it's going to 2 hours. The second one is do the make up some other days.